Hello everyone. Today I'm going to discuss with you electrolysis. This is O-level lesson. So this electrolysis particular lesson will be two sessions. There will be two videos. The first video I'm going to discuss with you one part of electrolysis, the very simple one, simplest form. And the next video will be discussing is like little advanced form. But to getting an idea, the fundamental idea about electrolysis, this video will be so useful. And this video only can it only long last maximum 4 minutes. So it's watching this video is will be a worth for you, right? We'll go to the electrolysis lesson. My dear, before we start electrolysis, just tell me what we call electrolysis. So electrolysis mean, okay, the term lysis called the breaking down, something breaking in the lysis, we are breaking things. And electrolysis means we are breaking something using electricity. So we'll try to get this particular definition into chemistry. So you are going to break compounds using electricity. And you are going to break this compound using electricity to their elements. So I'll write you an example. See, we have sodium chloride. Just get an idea. And you're going to make it sodium and chlorine again. So this particular process we call electrolysis. And when I'm doing electrolysis, I have a particular apparatus, very specific apparatus. So this apparatus we call electrolytic cell. So I'm going to draw that particular apparatus down here. So this apparatus, yes, I have a very simply a beaker. And these two beaker, I'm going to immerse two rods. Those rods we are using in O-level. Those are made on carbon, or you can say graphite, 1 allotrope of carbon, or else you can use a metal such as platinum. But somehow, my dear, these two metal rods has to be inert because in O-level we are discussing only inert electrodes. So this carbon and the platinum are inert electrodes, inert metal rods. Yes, obviously. These two particular rods we call as electrodes. So those we call electrodes. Okay, those electrodes when you connect to a battery. So this particular electrode will be positively charged, other one will be a negatively charged. So I have two types of electrode, positive and negative. So these positive and negative electrodes we can define as anode and cathode. So please remember the positive electrode we call as anode. And the negative electrode we call as cathode. And you might say, sir, this is two electrodes are there, is fine, but we need to remember it. Yes, we have to remember it. That's the way of remember that anode and the cathode, which is positive and the negative. Just remember this particular term, panic. It says positive anode and the negative is cathode. Right, this particular term, just remember, it says positive is anode and the negative is cathode. You can remember that. So electrodes are fine. We said the electrodes, those can be carbon, graphite, or platinum. And the particular thing you are going to electrolyze, the thing in the beaker here, this particular thing we call electrolyte. This electrolyte has to be an electrical conductor, my dear. Otherwise, you can't do electrolysis here. So these two, this particular electrical conductor, there are two types of electrolytes we are learning in O-level. So what are those electrolytes? Just remember, solution form of them, solution form, and the molten form. I'll explain them. The solution mean, let's take an example as sodium chloride. Sodium chloride aqueous, we call it the solution form. And the molten form, sodium chloride liquid form. So once you heat sodium chloride solid, we know ionic compounds do not conduct electricity. So when you heat it, that become molten form. So the molten form of ionic compounds, they do conduct electricity, no? Because they have free mobile ions, not the free mobile electrons. Okay. So today I'm going to discuss with you electrolysis of molten compounds, not the aqueous solutions. So aqueous solution will be coming in another video, right? So before we go to the electrolysis of molten compounds, I have another things to explain you guys. On the cathode and anode concerning, I told you these are positive and the negative charges. No, so we'll see as an example. Suppose we have Na plus and the Cl minus ions in this electrolyte. So Cl minus ions will be attracted to the positive charge electrode, and the Na plus ions are attracting to the negative charge electrodes. So therefore, these positive ions and the negative charge and the negative charge ions, we can call them as cathode and the anode, because the negative ions always attracting to the anode. So using this term, I can call them as anions. And the positive charge ions always attracting to the cathode. So therefore, these positive charge ions, we call them as cations. So just remember, positive charge stuff we call cations, and the negative charge things we call anion, and the positive charge things we call cations. Right. We'll see what other reactions are taking place on the cathode and the anode, because these reactions are very important, guys. In the exam, they directly ask what other reactions are taking place on the cathode and the anode. And I hope before this lesson, you have learned the redox, the oxidation and the reduction lesson earlier. Right, we'll see what other reactions are taking place. When you're concerning anode, remember, always oxidation is taking place. If you concern cathode, reduction is taking place. So you might say there are a lot to remember, sir. The panic, the positive anode, negative is cathode is fine. We can remember it. How we can remember anode oxidation and the cathode reduction? I have another term for you. Just remember red cat. We have a red color cat, red cat. Just remember this term, red cat. It says reduction is taking place at the cathode. Okay, those are the main very simple introduction for electrolysis lesson. And my dear, one more point, just remember, whatever the ions in electrolyte, those all will be discharged at the end. Discharge means they lose their charge. I'll explain those. Just remember this point as well. All ions discharge. Discharge means they lose their charge. So whatever the Cl minus, suppose there, that becomes Cl. Suppose we have Pb2 plus, that become Pb. So all ions will lose their charge and become the neutral form. So we'll go to the examples. So we'll take the heading, electrolysis of molten compounds. I'm going to discuss with you electrolysis of molten compounds with this video. So when you're electrolyzing molten compound, very easy. We'll get the first example. Sodium chloride. Sodium chloride is very common example, you know, guys know. Suppose sodium chloride solid when you take, my dear, suppose when you put sodium chloride solid into beaker and you immerse two electrodes and you are going to do electrolysis, that never happened, because sodium chloride solid is an ionic compound that doesn't have any free mobile ions. So therefore that won't be conduct electricity. So that won't be electrolyzed. So therefore you have to heat it to make it molten compound. So when you heat it, that become molten, which is sodium chloride liquid. When you concerning sodium chloride liquid, yes, I can say ions. What are the ions we have? Na plus liquid and the Cl minus liquid. So state symbols comes with the liquid form here, because the molten compound we have. We'll see what other reactions are taking place. When you get anode, which is positively charged, so therefore all the negative ions are coming and the reaction is taking place, oxidation. So negative ions is Cl minus liquid forms that lose their charge. Remember the fact, always whatever the ions comes to the electrodes, they lose their charges. So Cl minus becomes Cl. Okay. And I told you, always on the anode taking place oxidation. You know, oxidation is losing electrons and the reduction is gaining electrons. So that particular term, we can remember oil rig. Oil rig mean losing oil rig oxidation is losing and the reduction is gaining electrons, right? So Cl minus liquid form become Cl. But okay, tell me how many electrons will be removed? Only one electron, no? Yeah. And Cl minus becomes Cl. You remember in the redox chemistry we learn always this chlorine, bromine, hydrogen stuff. We write as a diatomic forms. Mainly just remember as a fact, not the fact, just remember. All the non-metals forms here, those will be diatomic forms. So Cl minus becomes Cl2, my dear. Cl2 is a gas. And if it is 2 here, therefore this has to be 2, and therefore this also has to be 2. So this is very simple anode reaction. We'll go to the cathode reaction. On the cathode, what is the reaction is taking place? Cathode is a negative charge 1. We know cathode reduction is taking place. To the cathode, positive ions are coming, cations. Na plus comes. And whatever the ions comes, they discharge. They lose their charge. So Na plus become Na. And on the cathode, always reduction is taking place, right? So therefore, Na plus gaining 1 electron, isn't it? Because Na plus requires only 1 electron to become Na again. So this is a liquid form. And the metal also form here will be liquid forms, right? So this is very simple. First example, I explain you about electrolysis of molten sodium chloride. We'll see another example. So already you understand the electrolysis of molten compounds. Second example, very famous, lead 2 bromide. The lead 2 bromides, once you heat it until it become molten, we can see ions, the free mobile ions. So what are the free mobile ions we have? The lead 2 bromide, the lead 2 bromides mean lead has to be Pb2 plus, the liquid form. And there are 2 bromide ions, 2 Br minus. Okay, so we'll see what are the anode and the cathode reactions. On the anode, you know what the negative ions are coming because anode is a positive charge 1 and the oxidation is taking place. So what are the negative ions we have here? Br minus. So Br minus comes. I told you this Br stuff anode, they become Br2, right? But before that, we'll try to balance this equation. Br minus become Br. Okay, they lose their charge. And the oxidation, losing electrons. Br minus become Br, losing 1 electron. And the Br has to be Br2, right? So therefore, this has to be 2 Br minus. Therefore, 2 electrons are here. And the non-metal forms, here gaseous form of Br2 will be getting. This is a liquid form. And the bromine is a brown color gas. You know, there are 2 brown color gases in chemistry. One is Br2. Other one is nitrogen dioxide. So as observation on the anode, you can see brown color gas form. As observation, they might ask from you. What is observation you can see on the anode? Brown color gas forms because Br2 gas forms. We'll go to the cathode. On the cathode, negative charge, reduction is taking place. So what are the ions here coming to the cathode? All the positive ions are coming because cathode is a negative charge. So Pb2 plus comes, liquid form, and that all will be discharged, losing their charge. On the cathode, reduction is taking place. So therefore, it gains electrons. How many electrons are needed? Yes, Pb2 plus mean it needs 2 electrons. So here has to be 2 electrons. And we are getting Pb liquid form. So those are the reactions are taking place when you're concerning molten compounds. So molten compound is so easy, my dears. So that's all the fundamental thing about the electrolysis of molten compounds. Find out some questions from some other resources from your textbooks and try to do molten electrolysis of molten compounds. In the next video, I'll explain you how we electrolyze aqueous solutions. And thank you very much for watching my video.